Thanks, Fabio. So I'm Withiel Cole. I lead the data science group within Symphony Retail AI, focused on the utilization of loyalty card data for retailers and CPGs. And I'll talk a little today about how we see AI, how it's changed the way we work, and some of the capabilities that it enables for retailers and manufacturers. So if I just move to the presentation a moment. Can you see my screen okay, Fabio?
I can see your screen. Okay, thank you. Wait.
Perfect. So what we're looking to cover is a definition of AI, and it's a difficult thing to define, about how we look at it. Some information on why it's become important in the modern world, particularly around the capabilities that technological advances have provided and enabled, and then examples of how we're utilizing those to provide real value to our clients. So first of all, we look and try and define what AI is. There are different ways of looking at it. It's not something where there's a very nice, neat description that you could find on the internet. In Symphony Retail AI, we look at it as a system, an algorithmic system that is replacing or directing a decision that would previously have required human intelligence. The point of a decision here is important, because if you're just looking to replace something that someone might have done with their intelligence, i.e. added up some numbers or written a sentence, then that's not necessarily the same thing. That's not getting to the action that drives value. So for us, it's about providing intelligent systems that either make a decision or direct a decision that someone is going to make. And that decision inevitably in a commercial environment is looking to drive revenue or profit. And so if you think about it from that perspective, it's looking to do something similar to mechanization did in terms of reducing the need for people's physical labor. It will reduce their need, or at least allow them to focus their mental effort in different areas. And that's where the big opportunity for AI is. We look at machine learning as a part of that, and in particular is something where you have a system which is wrapped in a way where it continues to learn. So you're able to feed in new data and the system updates and it's self-learning. So an AI algorithm can look at a situation, but it doesn't necessarily continue to learn without data being fed to it, whereas we would see a machine learning solution as something where the data is updating and the algorithms are updating and responding to changes in the environment. When we look at the reasons that AI has become important, there are predominantly technological advances, but they particularly relate to a couple of things. First of all, the technological advances have enabled types of algorithms that can learn from complex environments in a way that orthodox approaches could not. And secondly, these technological advances have given us greater scale and capacity and speed to deploy these models. Things that would have taken hours before to train or score are now available to run in much shorter timeframes. So those algorithms that are available now, they can deal with a much more complex reality than orthodox statistical models that might say that as A increases, so does B, or as X decreases, so does Y. You may take logs or transform that in some way, but that type of model does not reflect the complexity of the real world. The technological advances have also given us the capability to build models that update with the latest data, and as I said, become machine learning. They're responding to shifts in the environment. We can process much greater volumes of data, which means you can build many more models, or you can build models on much greater volumes of data, which helps them to learn some of these complex relationships. And we can link multiple algorithms together. So as an example, when you're looking at the type of impacts on demand or profit in a retailer or manufacturer scenario, there are multiple factors, from the traditional perspectives that a retailer or manufacturer would tend to look at when trying to determine the drives of their demand. So is it brands, is it sizes, is it flavors, particular pack types? Typical dimensions that all retailers and manufacturers are looking at. There can be external factors like the weather or particular events that have occurred, as well as actions of competition. All of these things interact together. They interact in what would be defined as non-linear ways. So you can't say specifically because the sun goes up and you put an item on promotion that those two things add together to have an effect. all of these things interact, they create a complicated environment, and the types of algorithms that are now available are much better at understanding that complexity than the types of algorithms that were previously available. In addition, you've got a much easier way to integrate these algorithms within technological environments than was previously the case. Algorithms have been utilized for many, many years, but typically those algorithms would take a substantial amount of time to build, and then they would be deployed. They would not update, they would be left to run, and it was not possible for them to update. Now, relatively easy to build an algorithm, to get that algorithm to continue to learn and to reflect the latest situations within that environment. You've got much greater capacity. So when we're looking at building models, you can build in some of our solutions where we're looking at promotions, for example, might be hundreds of thousands or millions of models to understand the impact of promotion on every individual line in every individual store. You can build models on huge volumes of data that help them to learn much more complex patterns. And when we're looking at something like personalized marketing, we would be doing that. And when you're building these models, they're much easier to integrate. They are readily available within the types of software solutions that we're deploying. And that means that they become part of a solution as opposed to an analytical role. Alongside all of this, when you're building AI solutions to problems, you're not saying, okay, I'm going to build this particular model. Often you're deploying sequences of models that help to learn and understand the complicated environments. So some approaches might be looking to understand some elements. So in the example there, to understand particularly what product choices mean. And then you may have other algorithms that are looking at how customers are potentially combining those choices or interacting those choices with particular mechanics. And then other algorithms that are looking to predict and make recommendations from this. So you can not just build a view of the world based on single algorithms, but you can combine these things together to make a complicated world understandable from that machine's perspective, and then predictable and make recommendations from that. To give an example about how that type of capability is utilized within our solutions and delivers real value and profit, talking about personalized marketing in retail or CPG, a retailer has huge volumes of offers that they could deliver to a potential client, potential customer. So they've got thousands and thousands of individual products, and for any one of those products, they could be looking to give various levels of discount to incentivize a customer. In order to solve the problem as to what offer to give to what customer, what we're looking to do is to solve two problems. First of all, understand how a customer might respond to any one of those individual offers. So will it make them use the offer, and will using that offer generate any additional behavior, any incremental value? And secondly, given that we know exactly what any individual offer is likely to do to any individual customer, what's the best way to deliver a mix of offers to all the different customers that you have, given the business constraints that you have? So talking a little more detail around those two approaches. First of all, we've got a machine learning cycle that's taking hundreds of different measures to understand exactly how engaged any individual customer might be for each offer. So that's hundreds of measures for each household for every single offer. They are used deploying an AI algorithm, a random forest type of algorithm, which is good at understanding this complex nonlinear relationships to predict for us what the chance of redeeming or the chance of incremental behavior is for every single customer, for every single offer. And typically we might have thousands of different offers within a campaign that we're looking to execute. It'll tell us one customer might have a 1 in 6 chance of redeeming one offer, or a 1 in 20 chance of redeeming another offer. That isn't the end of the problem. Then we've got to make a decision about what particular offer to give each customer. It's highly unlikely that we can simply pick the best offer. There are situations where that's the case, but in many situations you can't simply pick the best offer for each customer, because each offer has a limit in terms of how many people it could go to. So with all these constraints, we're looking to solve a very complicated problem where, and this is very typical, we might be looking to give every customer 6 offers from a pool of potentially 1,000, and that 6 offers should be ordered from the best to the worst for that individual customer. There are huge potential numbers of combinations of offers that we could deliver to each customer from that, and we use an iterative type of optimization approach to select the best offers for every customer, given a range of business constraints. So each offer could maybe only go to 100,000 customers or 200,000 customers. You might not want to have 2 offers from the same category or from competing products. You might want to have a specified total level of investment as a minimum for every customer. Each of these constraints can be applied in such a way that the optimization will then ensure that the best outcome possible, given your business constraints and our understanding of the likelihood of response, can be delivered. The results of this, in comparison to a non-AI based but heavily sector knowledge driven solution, was tested in a retailer in the US, where we drove over 50% increases in participation and redemption, and then around about a 15% increase in sales lift, as well as identifying more customers, an 8% improvement in eligibility. The AI algorithms were able to identify more potential customers for every single offer than the business rules had. Obviously, this type of comparison, it depends on what that baseline is, what you're trying to improve upon, but consistently we do see significant benefit to utilizing this type of technology to deliver better, more accurate, personalized communication. That's one example. We currently are utilizing AI and ML approaches in our promotion solutions to identify the best ways to maximize revenue and margin from in-store promotions. We're using them within our category planning application to optimize assortment and to understand how demand transfers. We use them heavily within our Cindy solution, which is looking to monitor the retail environment and give recommendations about the best actions. And as I just talked about within the personalized marketing space, to help you to maximize revenues and engage clients through those personalized communications. That capability for us is enabled not just as a data science platform, but delivered through end user solutions that provide the capability hands-on to a commercial user, not something that is in the hands of a data scientist. So hopefully that's fit into the time required. And any questions, Fabio, or back to you?
Thank you, Whit. Again, very interesting topic, and I'd like just to stress one point that you made up front, which is, in your view, the advancements in AI really frees people time so that the machine can do the substantial part of the work, and people can really interact in a more complex situations, can use their time better. Is that a correct understanding of the potential?
So. I don't think we're in a situation where machine learning can yet solve all the problems that a human can do, and actually some of those things that humans are still very valuable in are some of the more complex strategic types of decisions that maybe it's not quite possible yet to coordinate AI algorithms to get towards. So while I see them as making it easier to make the easier decisions, they're not yet in a place where we're using them to make the most complicated, the most difficult decisions. And I think that's likely to remain the way. So it will free us up from making some of the more smaller tactical decisions and mean that people are able to focus on making bigger strategic ones.
Thank you. That's a very interesting and thought-provoking point of view. Thank you very much for your presentation. Thank you.
Thanks, Fabian.